to find what is the ammeter reading in this simple DC circuits. Over here we see that is 4 ohm and 12 ohm. These two resistors, they are in parallel. So we can convert this circuit into a simpler DC circuit where 4 and 12, these are the two resistors which are in parallel. So 1 by R equivalent is equal to 1 by 4 plus 1 by 12 we have done earlier also. So R equivalent comes out to be 3 ohm. So what we can do is, we can, instead of 4 and 12 ohm which are put across AB, we say A is here, B is here, we have cut it, we have removed it, and instead of these two resistors we have put a one single resistor, and the battery will not come to know of the changes what we have done. Battery will not come to know the changes what we have done. It means that is from the same battery the same current will still be drawn as it was being drawn earlier when these two resistances, they were in parallel. So over here this is 24 volt, and if we say over here that is A ammeter, so V is equal to IR, we can use it. V is 24 volt is equal to I is, we don't know, into R is 3. So I comes out to be 24 by 3, that is 8 ampere. So this is one way where we have seen the resistances, they are in parallel. We have found the equivalent resistance. Then we use directly V is equal to IR and we get the answer. Generally when the students, they see the resistances, they are in series and parallel, so they are in a hurry to find what is the equivalent resistance. You can always emphasize on the point whether there is genuinely a need to find the equivalent resistance of the circuit or not. Like in this case, if we have to find this ammeter reading, this can also be found without finding the equivalent resistance. How? That is, the potential difference across AB is 24 volt only. Whether we take this path or we take this path, so whatsoever current comes over here, that is, if we say I current is going from here, so I1 current will be here and I2 current will be here. Because the conservation of charges, I is going to be equal to I1 plus I2. So obviously whatsoever current goes over here, this only gets split into these two. That is, some current passes through the 4 ohm resistor and the rest of the current, obviously it has to pass through the 12 ohm resistor only. So when we say I is equal to I1 plus I2 and the potential difference across AB, that is both the resistors, that is equal to 24 volt, for this if we use, that is V is equal to IR, for this resistor if we use, so we say V is 24, I1 into R, that is 4, so I1 is equal to 6 ampere. I1 is 6 ampere. If we see this 12 ohm resistor across this also, what is the potential difference? So what is the potential difference across this 12 ohm resistor? This says we can use V is equal to IR once again. V across this is 24 volt, I is I2, R is 12, so I2 is going to be 2 ampere. So in this it goes 2 ampere, and over here this is 6 ampere. 2 plus 6, 8 ampere will be equal to, so I is going to be 8 ampere, that is the current. Without finding the equivalent resistance in this circuit, we have found what is the current which shall be coming out of the battery and what are the currents in the 2 amps.